So today we're going to talk about surface area and volume of different shapes. Now for the notes part 1, we're going to concentrate on rectangular prisms, cylinders, and cones. Now just a reminder, surface area is the number of squared units it takes to cover a three-dimensional figure. Now on your formula sheet you'll see the letters L, H. Now L represents the slant height of the 3D figure. Now remember, slant height would be your hypotenuse, and you can use Pythagorean theorem to determine the slant height. And then H represents the actual height of the 3D figure, and this would just be one of the legs of that right triangle. And now in the nets that you'll be seeing, it's a 3D figure broken down, or in other words, flattened into two-dimensional parts. So the first figure we're going to look at is a rectangular prism. So the rectangular prism, okay, the first thing I did was to label each as the length, the width, and the height. Now, as long as you're consistent, it does not matter which one's the length, the width, and the height. Is just so that way you know when you're plugging into the formula. So if you look at the net, okay, you can see how this rectangular prism is taken apart, kind of unfolded into a two-dimensional figure. Now, the formula for the surface area of a rectangular prism is 2 length times width plus 2 length times height plus 2 width times height. So what that means is that the length times the width would be the area of the bottom, and so we're just going to multiply by 2 because the top and bottom are identical in a rectangular prism. And then 2 length times height would be one of the sides, would be the length times the height, and then of course opposite to that would be the exact same. And then we have the width times the height, and then you're going to double that. So to find the surface area for the first example, I'm going to figure out the first part. So the 2 length times width. So I'm going to plug in 10 for length and 5 for W because that's what I designated from the beginning. So that's equal to 100. Then we have 2 times 10 times 6 for the length and height, which is equal to 120. And then 2 times 5 times 6 is equal to 60. Now, what you're going to do is once you've determined all those areas is you're going to add them together and get an answer of 280 meters squared, remembering that our units for surface area is always squared. So that's just using the formula for the rectangular prism. Now moving on to the cylinder. Now the surface area of the cylinder is saying that we're going to do 2 times pi times the radius squared plus 2 times pi times the radius times the height. Now remember, r is the radius of the circle, h is the height of the cylinder, or in other words, the distance between the circles, and lateral area we'll talk about in just a second. So cylinder here, just like you think about it as a can, if you look to the net, okay, when you flatten this out to a two-dimensional figure, you get a rectangle with 2 circles, okay, and the bases are the circles, and then the curved surface, or in other words, the lateral area. Now, when we're solving for surface area, we need the radius and not the diameter. The image that's given to us here says we have a diameter of 10 centimeters. So now we know that's going to be a radius of 5 centimeters. So first thing we want to do is substitute it into the formula. So we know that just for the first part, we're going to use 3.14 for pi. So 2 times 3.14 times the radius of 5 squared is equal to 157. Next, we're going to do 2 times pi times r times h. So 2 times 3.14 for pi times 5 for the radius and 12 for the height of the cylinder. That comes out to 376.8. And our last step will be to add. And when we add those two together, we get 533.8 centimeters squared. Now, okay, going back to lateral area. So lateral area would be just to find the area of the curved surface. In other words, if we're looking for the label around a can, because the label only goes around and does not cover the top and bottom. So the surface area formula for the lateral area would just be 2 pi rh, or the second part of the formula, because that is how we get the formula of that rectangular shape label. Now, moving on to cones. Okay, now on the cone, we identified that the height of the cone, remember height, not the slant height, h is equal to 20. The slant height, okay, of the cone is 21.54. and the radius here is equal to 6. Now it's very important to be able to distinguish between height and slant height here. Now if you look at the net of the cone, okay, you have a circle and then the curved surface kind of breaks apart. Now the surface area formula would be the pi times the radius squared plus pi times the radius times the slant height. Now if you look carefully, okay, pi r squared, okay, is just the area of the base, and that's the formula for a circle, okay, and then pi r L is the area of the curved surface. So we're adding those two areas together to find the surface area. Now here, the surface area, the first thing we're going to do is find the area of the base, or an area of the circle. So that's going to be 3.14 times the radius 8 squared. Okay, so it comes out to 200.96. Now if we keep looking, the next thing we're going to do is find the area of the curved surface. So that's the second part of the formula. So we're going to do 3.14 for pi times the radius 8 times the slant height of 21.54. And that comes out to 541.08. So the last thing we have to do here is add them together to find the total surface area, which comes out to 742.04, and then units squared since they didn't identify specific units. Now go ahead and move on to the back of your paper for volume. So with volume, notes part 1, we're still talking about rectangular prisms, cones, and cylinders here. So now remember that the volume is the number of cubic units it takes to fill an object. So volume in the area is the area of the 3D shape of the base times the height of the 3D figure. So it's going to be the same thing for each shape. It just, the area of each base changes depending on the shape. So the first one we're going to look at is rectangular prisms. Here we've labeled the length as 6, the width as 4, and the height as 5. Okay, and the formula just means I'm going to do the length times the width times the height. So to find the volume, you just multiply all those three numbers together. So I have 6 times 4 times 5, okay, and we get an answer of 120 centimeters cubed, remembering that we cube our units for volume. Now the next figure we're going to look at is a cylinder. Now a cylinder here, same as before, it's given us a diameter of 10 centimeters, so that means our radius is 5 centimeters, exactly half of that. And the height of the cylinder, or in other words, the distance between the two circles, is 12 centimeters. Now to find the volume of a cylinder, you're going to do pi times r squared times height. So still using 3.14 for pi, we're going to do 3.14 times the radius of 5 centimeters squared times the height of 12. Okay, so don't forget to square your 5 first to get 25, and now we can do 3.14 times 25 times 12 and get an answer of 942 centimeters cubed. Now always remember to square before you multiply. Exponents come before multiplication in order of operations. Now for the cone. Okay, the height of the cone itself here, not the slant height, it's very important to remember that, is 20. The radius is 8, and then we will not be using the slant height at all, so we did not label it. So the volume is 1/3 times pi times the radius squared times the height of the cone. So here, pi r squared comes from the area of the base, or in other words, the area of the circle. H comes from the height of the cone, and remembering not to use the slant height here. So to find the volume, we're going to substitute in 3.14 for pi. The radius is 8. And we're going to square it and then times the height of 20. So remember once again to square, the radius first. So now we have 1/3 times 3.14 times 64 times 20. Now we can't round 1/3 to 0.3. We have to leave it as 0.3 repeating. So we can multiply our 3.14, 64, and 20 first, and then divide by 3 at the end, or just simply do 1 divided by 3 and leave it as 0.3 repeating in the calculator and then multiply the next three numbers. And our volume comes out to be 1,339.73 units cubed. Now go ahead and find the volume of each of the following three-dimensional shapes. So pause the video and then check your answers. Now the answer for the first cone formula, okay, remember to use 1/3 pi r squared times h. You get an answer of 314 meters cubed. For the rectangular prism, that's 8 by 3 by 5. Remember, all you're doing is length times width times height, and we get an answer of 120 inches cubed. And for the cylinder, you're using the formula pi r squared times h, okay? And our answer comes out to be 2,154.04 inches cubed. So that concludes our notes on surface area and volume part 1.